Hello. What a beautiful Thursday it is. Today we are going to be taking a look at proving those quadrilaterals. Yeah, we're proving quadrilaterals, squirrel. This is one of the last lessons of this unit. I know. Once we're done with the homework is proving quadrilaterals, and then we're going to move on to the last lesson of advanced proofs. You survived! I know it was tough. I think you can do this, though. We are super close. All right, let's take a look. Statement, reason, and then our givens, of course. BE equals EC. So BE equals EC. Given. And then E is the midpoint of AD. Good job, score. That's our second given. And midpoint means we need to do definition of midpoint. That's very important. The definition of midpoint, AD is cut into two equal pieces. So AD is cut into AE and ED. Okay. We need to prove that this sucker is a parallelogram. We have now run out of givens. That's exciting. Well, first thing that we always have to do when proving a parallelogram, it starts with a quadrilateral and then goes to our three different things. If we want to prove parallelogram, we have to start at quadrilateral. So we better be saying quadrilateral, A, B, D, C is a quadrilateral. And we can say that because four sides. Okay, now let's take a look at what we have to prove that it's a parallelogram. Now, if you remember, we've got those 6 different things that prove it's a parallelogram. And your homework was not to do this proof. It was to write out the givens, which you should have gotten. And of course, the definition of midpoint, because come on now. But I wanted you to look at those 6 givens and tell me which one would be the easiest to go from these givens. So we've got 2 pairs sides parallel, 2 pairs sides congruent. Good job, squirrel. And then 2 pairs angles congruent. Yeah, and then what was the next one? Consecutive angles sum to 180. And then the next one. Oh, squirrel's given up. She can only get the first 4. It's rough. Okay, the 5th one, diagonals bisect each other. And then the 6th one is 1 pair sides parallel and congruent. Okay, now I could prove 2 pairs of sides parallel. I could prove that the pink triangle and the blue triangle are congruent and get AB and CD. And then I could prove that the side triangles are congruent and prove AC is parallel to BD. I could do the same thing with congruent. If I wanted to prove 2 pairs of angles, I would have to prove that the triangles are congruent. Then I would have to do angle addition because it means this full angle over here and this full angle over there. So that would involve proving 2 sets of triangles congruent and then doing angle addition. This guy, as I said, is useless unless you're doing a maze problem. So we're not going to deal with that guy. This guy's not too hard to prove because I could just prove this triangle and this triangle, and then I'd prove those by the angles from CPCTC and sides from CPCTC. So I could do it that way. However, the easiest way to do this is diagonals bisect each other. Diagonals are what cut in through diagonally through the shape. Diagonals bisecting each other mean those diagonals are chopped up, and we already have that. That is actually the best one to use for this proof. As I say, you could use pretty much everyone except for number 4, and you could prove it with everyone except for number 4. And depending on what you do, depends on how long your proof is. This one is definitely the easiest because we can say, okay, we've got this guy here and this guy here, which means diagonals bisect each other. And that's definition of bisection. That's because I've got the BE equals EC and the AE equals ED. And then I can say ABDC is parallelogram, because diagonals bisect each other. And that's all you had to do. So if you had done the givens, and of course definition of the midpoint, because that's what always happens when you have such a given, you were pretty much halfway done with this proof. All you had to do is go to quad and then use one of those 6 things to prove it was a parallelogram. And the easiest one to use was the 5th one. Now, the problem is when you get to the Regents, you might not have all 6 of these memorized, in which case you're going to have to go with whichever one you do have memorized. So the more you have memorized, the better. Okay, before we move on, I want to talk about number 3. Number 1 should look like this, should be all done. We've talked about how to prove its parallelogram. I want to talk about what happens if we have to prove something is like a rhombus. And once again, this is incorrect. This should be ABC. All right, do our statement reason chart just like normal. And start with our givens. CD equals DB given. CD equals DB. Next one is measure angle CAD equals measure angle DEB. So CAD and DEB. Okay, that's given. And then AE is perpendicular to CB. Given, of course, perpendicular means definition of perpendicular, which means there better be a 90-degree angle somewhere. And that's AE and CB, which means there are actually going to be 4 different. All of those angles at D are going to be equal to each other. They're going to be perpendicular. So we are going to say measure angle CDA, measure angle ADB, measure angle EDB, and measure angle EDC. They are all equal to each other and they all equal 90. That is the definition of perpendicular. Okay. Let's get those right angles in there, right there at D. So now we got our givens down. let's take a look at what our chart says. So we've got quadrilateral. Quadrilateral has three things, one being parallelogram, kite, and trapezoid. And then parallelogram has rectangle and rhombus. So I need to start all the way up at quadrilateral. And I can say ABC is a quad because it has four sides. Woot! Done! Quadrilateral has been completed. Now we need to prove its parallelogram. So there are those 6 things to prove its parallelogram. If you write them down every single time, it's easier to memorize them. 2 pairs, sides, parallel. 2 pairs, sides, congruent. 2 pairs, angles, congruent. Consecutive angles equal 180. Diagonals bisect each other. And 1 pair, sides, congruent, and parallel. Okay. At this point, we cannot prove 2 sides parallel. We can prove that this side is parallel to this side because we've got that angle at A and E. So I can go from purple to purple. But I cannot prove this side and this side because there's nothing that goes from purple to purple. So proving 2 pairs of sides parallel could be difficult. Proving 2 sides congruent could be difficult. I would need to prove this triangle and this triangle, and then this triangle and this triangle. And the last 2 triangles don't even have the angles necessary. You're right, squirrel. We just said we can prove this side parallel, and we can prove this triangle and this triangle congruent. That would fit in with number 6. 1 pair of sides congruent and parallel. All right. So now we've got a mission now. I want to prove 1 pair of sides both congruent and parallel. Okay. In order to do that, we want to do the 2 triangles are congruent. So I'm going to say triangle ADC is congruent to triangle ADC, and EDB by angle side. Okay, so we've got the 2 triangles congruent. Let's get those 2 sides congruent. I want to get this guy and this guy congruent. And I can do that now because my purple triangles are congruent, so I can say that AC equals BE because corresponding parts in congruent triangles congruent. Okay. So I've got 1 pair of sides congruent. Now I need 1 pair of sides parallel. In order to get 1 pair of sides parallel, I need to use those green angles because those green angles attach this red to red and red to red. So I'm going to say AC is parallel to EB because blank, congruent blank, form parallel lines on transversal. color in between the parallel lines, I notice that my purple triangles are inside. So that would be alternate interior angles. Okay, at that point, I can say A, B, E, C is a parallelogram because one pair of opposite sides is both congruent and parallel. Okay, so we've proven parallelogram. And if that was our mission, we'd be done. We have proven parallelogram. Cha-ching for quad, cha-ching for parallelogram. And if we were on 1 or 2, where it says prove parallelogram, we'd be done. We're not done. No, indeed. We need to go all the way to rhombus. We need to figure out what makes it a rhombus. Well, rhombus has another set of things that we need to know. Okay, so what makes a rhombus? 1, it needs to be a parallelogram. We've got that. 2, what makes this parallelogram a rhombus? All sides congruent. Well, we don't have that, so that's annoying. We might be able to get it, but it would be tricky. Very tricky. 2, 3. We need to prove diagonals are perpendicular. Hey, wait! Hey, wait, we have that! We've got that! So yeah, all we have to do, A, B, E, C is a rhombus because diagonals are perpendicular. We had that. That was actually given to us. Sneaky, sneaky little critter. All right. Notice that one given helps me prove the 2 triangles and then did a double duty down here. Just because you've used a given doesn't mean you're necessarily done with the given. So just keep your eyes out for that. There's also one more thing for rhombus. Check it out because there is something missing there for rhombus. But at this point, we found rhombus and we're done with rhombus. So that would be how you prove something is a rhombus. If I wanted to go forward and prove it's a square, that's a whole nother issue. We're not going to go that far. The Regents normally doesn't. Right now, I want to go on to another completely different set of proofs. So let's take a look at today's notes. Today's notes, we're going to prove basic relationships. So we're going to take a look at what things they will give you as basic relationships. First thing, got a nice line, and we've got angle 1, 2, and 3. Measure angle 1 plus measure angle 2 plus measure angle 3 better equal 180. Yes. Those are angles in a line, right? That's helped us in our maze problems, and it's helped us in some proofs when we're doing linear pairs. That's going to help us again today. Let's take a look at the next one. If I've got something that looks like this. 1, 2, 3, 4, 5, 6. All 6 of those angles. Measure angle 1 plus measure angle 2 plus measure angle 3. Measure angle 4 plus measure angle 5 plus measure angle 6. Those suckers, they all have to add to equal 360 degrees. That would be what angles at a point look like. Angles about a point. Also important that we're going to need to know. A triangle. 1, 2, 3. Measure angle 1 plus measure angle 2 plus measure angle 3. They equal 180 because the sum of angles in a triangle equal 180. If you've noticed, these are all rules that we've done before. I have not taught you anything new yet. These are all basic rules that we've talked about before, and normally we do for maze problems. This is where the maze and the proofs coincide. It's very, very rare that they'll do it with a quadrilateral, but sometimes they do. These are maze plus proofs. This is where the maze meets the proof, and it's just an ugly, ugly meeting. All right, and let's do one more. If we have a quadrilateral of some manner, 1, 2, 3, 4. Sorry, 1, 2, 3, 4. Measure angle 1 plus measure angle 2 plus measure angle 3 plus measure angle 4 has to equal 360 because the sum of angles in a quadrilateral equal 360. Sometimes they will talk about that scary one from the parallelograms, the one that I've been saying isn't very helpful with proofs. It is helpful for these proofs. These proofs are when you have a nice parallelogram, it tells you it's a parallelogram, then you can say that measure angle 1 plus measure angle 2 have to equal 180. Because consecutive angles in a parallelogram sum to 180 degrees. As I say, very rare that we would use this guy. Even when the maze meets the proofs, it's very weird that we would use that last guy, but sometimes he does show up. So keep an eye out for that guy because he's just a weirdo. Most of the time, though, we'll be using these guys. Those are my favorites. I want to try and take a look at the homework and see what's happening on the homework. All right. Prove that measure angle x plus measure angle y equals measure angle z. Okay. So we gotta do our statement reason chart. And very rarely will they actually give you any givens. Like no givens except for the picture. And sometimes they won't even label all of the angles. So let's label this guy because he's sort of just being left out. All right, let's take a look at the picture is what's given. That is the only thing that's given. So sometimes you write that down, but you don't even need to write that the picture is given. In the picture, there are two different things. I see a triangle right here. If I'm looking at my list of things to keep an eye out for, triangle is an option. So, since I see a triangle, I'm going to highlight the fact that there's a triangle there. And I'm going to say measure angle x plus measure angle w plus measure angle y equals 180. And I know it equals 180 because angles in a triangle sum to 180. Okay. So I see that there's a triangle. I notice that there is a triangle. So I say something about the triangle. Next thing I want to say about this guy right here. This guy is a line. And lines were another thing that we were supposed to take a look at. We've got a nice linear pair there. So I'm going to use that. And I'm going to say measure angle W plus measure angle Z equals 180 by angles on a line equals 180 or linear pairs. Doesn't matter. Okay, now I have two things equaling 180. Because I have two things equaling 180, I can put those together into one big thing. So measure angle X plus measure angle W plus measure angle Y equals measure angle W plus measure angle Z. We call that substitution if you're putting it all in one big, long equation. Okay, so we've got nice substitution right there. And if you notice, there's something in that big, long line that is the same. We could subtract those two. If we subtract that, that means measure angle X plus measure angle Y equals measure angle Z. All I'm doing is I'm subtracting that measure angle W. So the measure angle W disappears from both sides. And hey, that's what I wanted to prove. Measure angle X plus measure angle Y equals measure angle Z. We're done. Notice, in this case, we're not proving two triangles are congruent. We're not proving parallel lines. There's no midpoint. There's no givens at all. These are very, very odd proofs because they're completely different from all the other proofs that we've been doing. However, are they really that different? What did we use? We used the picture. Well, we've done that before in our circle geometry stuff. We've used linear pairs. We did that in basic proofs. We've done angles in a triangle. We learned that in like Unit 2. And then we did substitution, very similar to what we always do with the linear pairs. And then subtraction. So, when we're doing these proofs, a lot of it seems familiar, but it's also completely different, just for fun. Let's take a look at number 4. I like number 4. The really good news is a lot of these tend to be fairly short. All right, statement, reason. Notice we've got X, Z, and Y, and nothing else is labeled. So I'm going to label A, B, and C in there, just, for fun. All right, and we are given the picture. The picture is given. And that's it. All right. Now, this is tricky. It looks like they want me to go all the way around the circle and do 360. But it doesn't say 360 here, it says 180 there. So they must not want me to go all the way around the circle. They must want me to do 180 degrees, okay? 180 degrees would be a line. So let's do a line right there. Okay. I've got a line. A line equals 180 degrees. I like the line equals 180 degrees. If I look at this part of the line, I've already got Z and I've got Y. Okay, so let's take a look at that. So measure angle Z plus measure angle B plus measure angle Y, that equals 180 degrees. And that's because angles on a line sum to 180 degrees. Okay. So I'm almost there. The only thing that's a problem is I've got a b, and I do not want it to be a b, I want it to be an x. But I noticed something very interesting about b and x. Measure angle b has to equal measure angle x. Why would measure angle b have to equal measure angle x? Squirrel's given up on the lesson. She's gone. So I guess I'll answer my own question. Measure angle b has to equal measure angle x because of vertical angles. Okay. So now all I have to do is I need to take this x and plug it in for the b. So measure angle z comes down. Instead of measure angle b, I can write measure angle x, since measure angle x is the same as measure angle b. And then plus measure angle y equals 180. And all I did was substitute. I substituted in the x for the b. At which point I've got x plus y plus z equals 180. It's a little bit out of order, but you could just leave it like that. For some of you, you're going to want to reorder it because you're very, very distinct about that and fairly OCD, and that is beautiful. Love that about you. If you want to reorder it, you can. Reordering something like that is called commutative. That's the commutative property. So if you want to, that is a step. However, yeah, the Regents considers that an optional step. I don't think it's optional, personally, because I'm very OCD, but the Regents considers that an optional step. So really, if you leave out the fact that the picture is given, this is a 3-step proof. One of the shortest proofs we've done. However, also one of the trickiest proofs we've done. Your mission. I want you to do number 3. I want you to try and do number 3 for homework. See if you can handle trying to prove that guy. Good news, every angle that matters is already labeled, and you're trying to take a look at making that 180 degrees. Good luck. If you have questions or issues, please message me. And have a wonderful day. I'll see you tomorrow. Now, tomorrow I'm going to do a nice short quiz going over this homework, the number 3, and I'll probably go up and do number 1 or go down to do number 5 or 6. Depends on my mood. So I'll do a few more practice examples, and then there will be a mini quiz just to make sure that you are actually paying attention to me and watching the videos. So take a look for that video and that quiz. No, that's tomorrow. The quiz is tomorrow. Yes, it's got to be on the videos. I need to make sure that they're actually watching. Well, because you're not very good at this, and I'm hoping they're better. I know, that was very mean. I'm sorry, Squirrel. I love you. All right. Goodbye, students. Talk to you later.